Do you see it? Okay. I'm working with BSH Home Appliances, and as that, I'm the managing director of the EUW initiative. I'm coming back to that, what we did so far in the meantime. Just let me start with the challenges we are facing in the next time. Christoph started in Bordeaux. Maria then came down to the smart cities. I'm now already in the smart home or smart building, and mainly focusing on energy management as one part of the management of smart home and smart building. And what we are facing, this is an example of Germany. For example, we are now switching off nuclear power plants until end of 2022. We, in the same time, want to reduce brown coal production, energy production with the same amount. So that means end of 22, beginning of 2023, we are reducing our baseline up to 30%. And this needs to be replaced by renewables. On the other side, what we also are facing is, do we have enough capacity regarding renewables until that time? Next part is EV rollout. This is only one example. EV rollout in Europe is starting now. Even if it is very reluctant until now, the expectation is that in 2025 we will have more than 5 million vehicles on the road, and in 2030 we might have more than 25 to 30 million on the road. And last but not least, Greta is also forcing us to help to get a big view on what happens on environment and so forth. So what does it mean if I now talk about vehicles? For example, we are facing 5 million vehicles. In the next couple of years, we have around about 20 million heat pumps installed at home. And looking onto the breaker at home, it might be if both are switched on or if a couple of them are switched on, it doesn't work anymore. Next picture, for example, if we now face the neighborhood, and I think specifically in Germany or in Europe, we know that there's a limited capacity of copper in the ground. And if I want to charge all the electric vehicles which may occur in the next couple of years, it doesn't work as well. So it means it needs to become managed. The result is in Germany, we are now discussing about reducing the power, the capacity you get at home and the smart grid connection point. So that means they are talking about reducing the guaranteed capacity up to 5 kilowatts, and the rest is offered on a flexible way. So that means you need to manage it. Yeah? And this is becoming regulatory in the next couple of years. This is also a very critical point for the solutions. Means, in a nutshell, the devices, the grid, and the manager, they need to talk to each other. It's no doubt about they need to know what happens on a specific level. The devices, for example, the washing machine needs to inform that it wants to wash and needs to consume 2 kilowatts, the car a little bit more, the heat pump as well, and so forth. They need to inform the management system so that the management system can calculate using own renewables, using the grid capacity. The grid needs to know what is expected in the next time, and so forth. And you see what we did is, until now, we have developed it based on EEBus solutions. I will come back to that later. But it's not the final status. How did we get to these kind of communication solutions right now? We talked, and the EUWS initiative is an association with lots of manufacturers on board, lots of other stakeholders on board. So that means we talk to each other and we set up working groups, and one of the working groups is, for example, the e-mobility working group. And one scenario is what happens today in public charging stations. Electric vehicles are today using either 1511.8 or 61.851 standard to communicate the charging to the charging point. We use the same and use that as a basis to communicate between the charging station and the management system at home. And this is a typical cycle. The car arrives at home, and the first, if you plug it in, it informs about the demand. This is, for example, the first. You see it here? Here, yeah. This is the first one. The first picture here, it informs about minimum requirements if I need to drive immediately away, typical requirement demand, and the maximum demand. Yeah? Then the feedback from the grid or from the management system could be, for example, hey, I have kind of limitation from the grid, from my PV panels, from my neighborhood solution, and so forth. It's the information about this is the maximum you can use at a specific time. And the third one is this could cost it for you if you want to use this solution. So it means green, for example, means this is a surplus. My PV system offers you it without any cost. The next one is the typical feed-in funding you get if you feed into the grid. And the last one, the last here, the red one, is if you get this amount of energy from the grid itself, it costs you this and that. This is what the calculation of the car does it already today. And out of that, it calculates the charging plan and sends it back to the management system. So that means both management system and car know what happens, how much does it cost. I, as a user, can interfere and can say, I accept this or not. And then it is aligned. It's mapped into the overall mapping of the energy provisioning in the home. So that means everybody is in line with that. We have developed lots of use cases in the meantime, coordinated EV charging, as I explained it right before, overload protection, measurement, and so forth. We are working on next level of use cases like here, state of charge, bidirectional charging, vehicle to the grid, vehicle to the home, and so forth. These are the next topics which are really necessary if, for example, a car wants also to support my home for a specific time, lack of energy at home, power limitation at grid connection point, and so forth. These are the use cases we are working on, specifically on e-mobility. And if you look onto this slide here, we have a couple of working groups, e-mobility, HVAC. HVAC has already defined lots of use cases. White goods, it's not that big portion, but it could help for a specific time if I have some issues at home or in the neighborhood. Also, white goods can help, inverters, grid interactions, and so forth. These are the use cases we have already developed, and the next are already in the pipeline. Then we have developed the language. And you see on the right side here the use cases. Here's the data model, the SPINE, we call it SPINE, Smart Premises Interoperable Neutral Message Exchange, SPINE resources and protocols. It's also capable to support the cloud connection. We have also developed a SHIP protocol, the technical protocol, how to convey information from A to B, and so forth. In line with the smart grid architecture model, which was developed by the M490 European project. Sorry, I'm missing the word now. Next, what we did is we used our SPINE toolbox, all our messages, and mapped it use case by use case that you really can develop and can implement it precisely so that interoperability is assured, use case by use case. And this helps us to really to keep on track with the communication between all the devices. Proof of concept. First of all, what we need to do is, if we have developed the language, if we have developed everything, we need to prove it. And we started already in 2017 at the European Commission. We had a huge demonstrator that was a starting point for a couple of projects. And this was the first step. We have shown that a Miele washing machine, Whirlpool dishwasher, Bosch tumble dryer, and so forth. They work together. They have been managed independently with the same language. And the second one is, then we have introduced the heat pump from Violent. We have used the charging station from Mannekes, only to tell you a couple of manufacturers which have already implemented it. We can talk about Porsche and Audi and so forth. This was the starting point in November 2017. In the meantime, we had a couple of proofs of concept. This is, for example, the Plugfest we have performed with Audi in Brussels, beginning of this year, with a couple of manufacturers using the charging stations. We have contracts, or we have a liaison with German sanitation, heating industry, with the BDH is the heating, the European heating industry, and further. And next one. This is part of projects. This is a summary of Germany. In the northern part of Germany, what we do is we introduce flexible tariffs to feed into the smart homes, to allow to start running a washing cycle or a heat pump cycle on a flexible way. This is only to verify. Until now, flexible tariffs are not allowed in many of the states in Europe. And this is to test and to verify, and then to influence also the politicians if that makes sense or not. What are the benefits, what are the cons, and so forth. On the other side, what we have here is, for example, C-Cells project in the south of Germany. What we want to do is to prove if a limitation in parking places, like company parking places and so on, if that fits, if that helps to manage the available energy and so forth. What you also see is that we take into account the different kind of standards, like 61850, 15118, 61851, and so forth. Next one is, next week we have a global grid interoperability project, Plugfest in Petten, European Commission. And this is the combination of public charging and home charging, home turf charging. What you see here is, for example, this is the home turf, where you have the washing machine and the smart wall box attached to a home management system, as well as here the public charging environment. What you see here is, for example, this is, we attach OpenADR, we attach 61850, we have here the home solution with the EUWS initiative, we have here OCPP 2.0, OCPP 1.6, and so forth. This gives us flexibility to ensure interoperability. And this will be tested next week, the full week, in Petten in the Netherlands. Next project is Interconnect. We started based on that with a huge project. This is now starting for the next 4 years. And in a nutshell, we will have pilots testing these capabilities in 7 countries with roughly 12 pilots, huge pilots, beginning with 50 households and up to 1,000 households, And I think David Ruhr, in the next one or two sessions, he will also give a presentation about this project. The intention is not only to prove the interoperability of devices in this context, it's also to allow to attach or to develop a kind of API or a kind of interface to the marketplace so that you have lots of applications available helping you as a customer at home. Interoperability, it's very easy. This is why I'm here. If everybody is using the EUW solution, we have already the interoperability, but this is not the case, yeah? You see it, and Christopher has already mentioned, the world looks different. So we have KNX, we have Modbus, we have OCF, we have Energy at Home, we have lots of more of that. And I started already in 2013 to try to harmonize first with the language, with the EUW spine language. We sat together with Energy at Home and defined to build up one language, one spine-based language. With others, it's not possible due to the reason that they have own targets or that there is a completely different field and so forth. It doesn't help. So that means we need to take into account interoperability is not assured if everybody's taking the same language. This is already the situation here. Specifically, if you now focus on the manufacturer developing a management system or a smart appliance, he needs to decide what to do. And let's assume he wants to manage different devices touched via the EUW spine solution or via KNX. Then, until now, he needs to map it, he needs to understand both solutions, and then he develops a specific interface for his own. The same is with these services into the grid. We have OpenADR, we have 61850, we have DLSM COSM, whatever else, yeah? So that doesn't help us. And that was the reason why I personally already started in 2012 with the very beginning of the SAREF project to really to support this project. We need a kind of ontology. If we don't have the same language, we should have the same meaning behind at least. We should have a kind of dictionary, as Maria has explained. We should use a kind of dictionary so that everybody knows what is behind and how to interpret and how to use it. This is the main purpose of SAREF. And then we can have lots of different applications on top. And this is what we also do. This is my last slide now. We already started last year, beginning of this year, in a project with the University of Dortmund in Germany and with the DFKI. This is the Artificial Institute in Germany, to build up SAREF and to extend it with linked data. I'm not an expert. Object modeling, or how it is called, Maria is the expert of that, but in that case, what we did is we used the RESTful web service, we used the linked data approach, we developed it or we implemented it in JSON. Then we mapped it once to Spine and the other ones to Hue, to Philips Hue, to KNX, and so forth. And it works. So that means the main target needs to be that application need to be independent from any specific solutions, so that ensures interoperability in the final at the final end. Thank you very much.
Thank you, Joseph. Yes. Any questions for Joseph?